Alright guys, so now we are going to look about the section 4.2, translation of the graphs of the sine and cosine functions. So now that we know the basic shape of the graph of the sine and cosine functions and how those graphs change when stretched vertically, y equal a sinus x, or horizontally, y equals sinus bx, we can look at the other linear transformation of vertical and horizontal shift. So practice, first review sinus x and cosinus x. I would encourage you, it's a good example for you on the side to try to represent again very quickly sinus x, but you know, from the trigonometric circle, I know that the sinus will be equal to 0. The sinus of the angle will be equal to 0 when the angle, in this case, the angle equal x, and I'm representing always y function of x, okay, y function of x. And I can see that when x equals 0, pi and 2 pi, I'm at 0. And when x equals pi over 2, I know my sinus of my angle will be equal to 1. And the angle will be equal to negative 1 for 3 pi over 2. Or negative pi over 2 if I go in the counterclockwise on the trigonometric circle. Same idea for the cosinus. I'll let you work on that. And let me at least write the period, and if I want to write the period, I can easily say that the period of my cosinus, or I could look at the period between there and there, the period is equal to 2 pi. I can easily define the period right there, or right here. That is a period, that is a period, and I know that the period is equal to 2 pi 2. Okay? Now, if I want to go back to the graphing of sinus 2x and on the other side 2 cosinus x, all right? One is shrinking horizontally, the other one has been stretched vertically. You have now the expression, but as you can see, when you compare sinus 2x, you can see that the period p, the period p, which was 2 pi previously, for sinus 2x, the period is going to be from x equals 0 to x equal pi over 2. That is the period right here. And this is the period equal pi over 2. I can easily see the period right here, okay? And I will end up exactly the same thing. The period equal pi over 2, okay? Now, if I look at the other one, the cosinus will be equal to 0. So basically, when I have y equal 2 times cosinus, I can see that the period still equal to 2 pi. The period still corresponds to x equal 2 pi. The period equal 2 pi. So we have him right here. The period will be equal to 2 pi. When I have sinus 2x, I change the period compared to sinus x. Remember, the period of sinus x is 2 pi. When I look at 2 cosinus x, I do not change the period compared with the equation y equal cosinus x, but I multiply by 2 the amplitude. Now the amplitude is equal to 2 and not just 1 like previously. So now look at the horizontal translation. If I want to recall from the algebra, if you have y equal f of x minus d, you will have a shift to the right. And if you have y equal f of x plus d, you will have a shift to the left. So the same result applied to the graph of the trigonometric function with 2 new vocabulary words. We call that phase shift. The expression x minus d that you plug into the trig function is called argument. Please pay attention to that every time we are introducing new vocabulary words. All right, so let's try to graph sinus x plus 3 pi over 4 over 2 periods. What I want to do is exactly the same methodology. Based on my trigonometric circle, where do I have the sinus of my angle? And in that case, the angle is x plus 3 pi over 4. When do I have the sinus of an angle equal to 0? Well, the sinus of my angle will be equal to 0 when the angle, in that case x plus 3 pi divided by 4, equal to 0 when the angle x plus 3 pi over 4 equal pi, and when the angle x plus 3 pi over 4 equal 2 pi. So, what does that mean for the value of x? Well, for the first one, I got x equal negative 3 pi over 4. When x will be equal to 3 pi, negative 3 pi over 4, the sinus of my angle will be equal to 0. When x will be equal to pi minus 3 pi over 4, which is going to be pi over 4, I will have the sinus of my angle x plus 3 pi over 4 equal to 0. And on the other hand, at the end, and for the last one, x will be equal to 2 pi minus 3 pi over 4, which is x equal 5 pi over 4. So when x equals 5 pi over 4, the sinus of my angle will be equal to 0. So the sinus of my angle equal to 0 when? We're having 3 pi over 4. So if pi over 2 is right here, half of it will be right there. So I know that at negative pi over 4 is right here, right there, and there, negative pi over 4. Pi over 2, it is negative 2 pi over 4. So therefore, I end up to have right there, negative 3 pi over 4. And right here, I got a 0. Obviously, I can easily now say right there, it's 3 pi over 4. So pi equals 4 pi over 4. And so 5 pi over 4 is right here. So at 5 pi over 4, I got another 0. Okay, so right here, I've got 5 pi over 4. It's another 0. And I said also at x equals pi over 4, which means around right here at pi over 4, I got a 0. Okay? So I can easily, by symmetry, 1, 2, 3, this is another 0. And can I have 1, 2, 3, this is another 0. Now, when do I have the sinus of my angle x plus 3 pi over 4 equal 1? When my angle x plus 3 pi over 4 is equal to pi over 2, therefore x equal pi over 2 minus 3 pi over 4, and end up by multiplying by 2 top and bottom to have the same denominator equal to minus pi over 4. So when x equal minus pi over 4, I know that I will be at 0, at 1, sorry. So I will be right here. This is my 1. Now, let's try to find the last one. What is the value of my angle that make my sinus of my angle equal to negative 1? That means that x plus 3 pi over 4 equal to 3 pi over 2. that is when my sinus will be equal to -1. I'd like to remind you that on the trigonometric circle, you are reading the value of your sinus on the vertical axis, and the value of the sinus are in between 1 and -1, and it's equal to 1 when the angle equals pi/2. This is what we did previously. And now we know that the sinus is equal to -1 when it's equal to 3 pi/2. So therefore we got x equal 3 pi/2 minus 3 pi/4. If I multiply by 2 top and bottom, the first fraction, in order for me to have the same denominator, I end up to have x equal 6 pi/4 minus 3 pi/4, and that gives me 3 pi/4. So if this is right here, pi/4, pi/2 will be 2 pi/4, and so I end up to have right there pi/3 pi/4. Therefore, 3 pi/4, I got sinus equal -1. So I can easily now, by effect of symmetry, I can easily define all the other value that will make my function equal to 0 or 1 or -1. So if I look at between the value of when my sinus equal -1 right here, and the value when my sinus equal 1, sorry, and when the value of my sinus of my angle equal -1, this is the equivalent of half of a period, and in between you have 1 pi/4, 2 pi/4, 3 pi/4, 4 pi/4. So basically you know that you will have 1 pi/4, 2 pi/4, 3 pi/4, 4 pi/4 to end up to have another value when the sinus will be equal to -1, to equal to 1. Same thing for the other, on the other side. You have a minus pi/4. Then you're going to the left for a half period of 4 pi/4, 1 pi/4, 2 pi/4, 3 pi/4, 4 pi/4. Okay, so we got minus pi/4, 1 pi/4, 2 pi/4, 3 pi/4, 4 pi/4 is right here. All right, and now I can easily graph my function because I know that's a 0. So let me take this. Here we go. There we go. And I can continue, so forth. Now, that was the method number 1. The method number 2 is to understand basically that because we have sinus x plus 3 pi/4, we have a shift to the left of 3 pi/4. Therefore, if I was drawing the sinus x, and let me just graph the value, the graph of the function y equals sinus x for you. So when you look at the function sinus x in red right here, and when you look at the function sinus x plus 3 pi/4, you realize that the point in blue at x equals 0 has shifted to the left of 1 pi/4, 2 pi/4, 3 pi/4, and now this is the new point, and all the points have shift of 3 pi/4 to the left. Guys, I will let you finish the problem number 3, which is minus 2 cosinus x negative pi over minus pi/4. This is pretty simple. And you know what? I think I will try to do another video just because I think it's going to be helpful for you.